Hello, everybody. Welcome to today's webinar, Embodied Carbon, Deeper Decarbonization of the Built Environment. I'm Izzy Sigrist, Project Analyst at New Buildings Institute. Before we begin, I just have a couple of housekeeping items to tell you about. First, you are muted and we cannot hear you. This helps keep our background noise down so everyone can hear the speakers better. I also want to direct you to the dashboard that you should be able to see on the right-hand side of your screen. If you're having technical difficulties and cannot see the slides or hear our speakers, you can use the question pane in the dashboard to let us know, and we can help you out. We will be taking questions along the way, so please type them into the question pane at any time. At the end of the webinar, you'll be given the opportunity to take a short survey. For those of you looking to receive AIA credits, please stay and provide your number in this survey or indicate if you need a certificate. And finally, I wanted to mention this webinar is being recorded. After the webinar, we'll send an email with a link to the presentation slides and a recording of the event. This will allow you to view on demand and forward to anyone else who you think might be interested in this information. And with that, I'll be turning it over to Webley.
Hello, everyone. My name is Webley Bowles. I am a senior project manager at New Buildings Institute. I'm an architect and I focus on promoting carbon neutral buildings through research, guidance, codes, and promotion. If you're not familiar with New Buildings Institute, we are a nonprofit based in Portland, Oregon. We conduct research on high performance building technologies. We use that intel to create different codes and policies on high performance buildings. And then we build market facing deliverables to support designers, building operators, and others to build a carbon neutral future. So that is part of our webinar today. Izzy, I might need a hand here. All right. So first, I want to thank San Diego Gas and Electric for supporting the webinar today. The Codes and Standards Implementation of Energy Efficiency Measure Program is designed to improve compliance with the state's, which is California, building and appliance energy codes and standards. So thank you to San Diego Gas and Electric for supporting this webinar. I'll kick off the discussion today with an introduction to what embodied carbon is and some different codes and policies at a pretty high level. Brandon will talk about all the work that the concrete industry has done to reduce carbon in concrete, and he'll share some suggestions as well. And then Luke will jump in and talk about the connection between policy and practice, how those come together with collaboration among professionals. We'll also provide a couple of project examples. And then we'll have a Q&A, we'll answer your questions, we'll give you our answers, you know the deal. So one other thing to mention, Izzy said this already, but I have to show you the learning objectives here. This is approved for one continuing education unit. The slides are being recorded, they will be shared later. After this live session, you will get a survey where you can indicate if you need continuing education credits. So let's jump in. So most of us know, if you've been in the, I am supposed to turn off my camera. Sorry about that. Most of us know that buildings account for about 40% of the global GHG emissions. And that value includes embodied carbon emissions, which is about 10%, maybe up to 15%, and operational emissions, which is about 30%. And operational carbon is usually pretty well understood by those that are in the high performance building world. And embodied carbon is the sum of all the emissions associated with the extraction, manufacturing, transportation, installation, and end of life of a material or product. So that's kind of the difference between the two. But when we talk about embodied carbon, it's not just the emissions associated with the development of a product. We also want to consider the emissions associated with the installation, maintenance, which could be like refinishing a wood floor, concrete floor, etc. Emissions associated with replacement or product disposal. So this chart uses an EU standard, EN 15878, and shows the carbon associated with all phases of a building's life cycle. So this is to show you that we're not just talking about the upfront embodied carbon, but actually the whole life. So starting at the top, the stage indicates the stage of life for a project, so for a building project. The module indicates the phase within the stage. For example, a product, there are two stages there. So in that red in that red and orange, you can see that there's two stages there. You may hear someone refer to a product's embodied carbon measuring the cradle to gate emissions, and this identifies the boundary conditions. It's the same as saying the product stage or modules A1 through A3. So there's a couple different ways to talk about it, and it's important to make sure that you're aware that there's different terms out there that mean similar things, and it could be very specific. So what materials are the biggest contributors to embodied carbon we should be concerned about? Generally, structures make up the largest part of the embodied carbon pie. For those that are familiar with the book, How Buildings Learn, it's a great book, highly recommend it. You probably understand that the building's life cycle, that there's different components within the building's life cycle. So the structure is replaced the least and the interiors are replaced way more frequently. So we need to consider the life cycle impacts and the replacement timeline, not just the initial products for a new construction project. Once you understand that aluminum is essentially congealed electricity and that bio-based products like wood are lower embodied carbon, you can start to consider lower carbon materials. But we still need some of those high carbon materials like concrete and other metals. So the text to the right here, we're not going to walk through all of this. This is more for reference. This is a great little resource that provides some actions that designers can take. So there's 3 things on this slide, but there's one huge thing that's missing, and that's mechanical, electrical, and plumbing. And I'll get to that in just a minute. So this chart from CLF, Carbon Leadership Forum, and AIA looks at operational carbon in 2 scenarios and embodied carbon in yellow. So there's 2 different building types in blue. The lighter blue is a code compliant building, and the darker blue is a high performance building. And the code compliant buildings often have a higher operational carbon compared to embodied carbon, where the reverse is true for highly efficient buildings. So when we compare the operational carbons to the embodied carbon, the upfront embodied carbon relates to the construction and occurs at milestones. This scenario, we have 0, 15, and 30 years. But during the construction and at major innovations, we see those tenant turnovers. So that's why we have that more embodied carbon. And operational carbon is flexible, so it can be reduced through energy efficiency measures by using lower carbon energy, unlike embodied carbon. So as with embodied carbon, we want to address that upfront before we even purchase anything, because we can't really put those emissions back into the machine after they've been released. So we need to address them early. And regardless of building type, size, location, there are 2 materials that dominate nearly every analysis, and that's concrete and steel. For commercial buildings, I should add. And steel in the US accounts for about 2% of US emissions and 6% of global emissions. And of the US emissions, about half of the steel goes into buildings, into the built environment specifically. And while concrete accounts for about 8% of global emissions, and nearly all of which is architectural or infrastructure related. But when addressing energy efficiency, we always start with the largest energy consuming end uses. It's a pretty familiar idea within high performance buildings. So similarly with embodied carbon, we want to address the materials that are used the most and have the largest carbon footprint. So if you're familiar with ByClean policies, it follows the same idea. Those are the higher carbon products that are being addressed first. So in California, that's looking at steel, glass, mineral wool, insulation. And we'll talk about that in just a moment. Now, I don't want to pick on any one material, specifically concrete and steel, because they always seem to come up in conversation because there's a lot of opportunities there. But we have other products like mechanical, electrical, and plumbing, or MEP, that can reduce their emissions either from material efficiency, so being kind of efficient with how they design the system itself, and then just by identifying the different systems that are being used. So this ARUP study shows that the slide before that I showed was the ARUP study. I didn't mention that. It shows that the services, which is the MEP, are about 20% of the carbon emissions of the case studies that they looked at. Other reports show that MEP emissions are about 50% of the embodied carbon on a project. This University of Washington study looks at different MEP systems in conventional code buildings compared to high performance buildings. This study didn't look at the whole building, so the values can't really be all encompassing, but they do shine a light that we need to better understand the embodied carbon of mechanical, electrical, and plumbing systems. So how do we know what the embodied carbon is for each product, excuse me? It's through EPDs, and environmental product declarations are the linchpin of all the data standards reporting right now, because it's raw data. It's a summary of the material, the product or material life cycle analysis, and it quantifies the impact of a product on the environment. They include a lot of different information, not just the global warming potential or carbon emissions from the upfront embodied carbon. But I want to stress that an EPD is really only data. The existence of an EPD does not mean that it meets a specific environmental standard. It's disclosing or declaring its environmental performance, and that's what's important to remember here. So I'm going to quickly look at a couple different policies, because there's a lot of policies that are taking place, and there's a lot of conversation about kind of what's next here. And I am wondering when my slide's going to move forward next. Okay. So there's this map is from Carbon Leadership Forum, and they have a great up-to-date map that shows the different activities that are happening around the country. I'm going to show you some California policies in just a second. You've probably heard of Buy Clean. It's a pretty common embodied carbon procurement policy that many states are considering passing. For instance, Oregon's Buy Clean policy passed, but its scope is only focused on infrastructures, not buildings. Vancouver, BC has a zoning code that requires whole building life cycle analysis for projects that are changing zoning code, while Denver code is planning to adopt green code provisions. So the reason why procurement policies and what's happening at the state level and jurisdictional level is so important is that 32% of the embodied carbon of construction in the US is attributed to public projects. So that is why these policies are moving forward. It's just so important that they lead by example. So in California, there's several policies around embodied carbon and probably many more to come. Marin County was probably the first with their concrete code, and it sets limits for concrete and cement. You can see those limits on the right. Buy Clean California requires that state-owned buildings need to procure materials that have the right global warming potential limits, and those are essentially set at the industry average. Assembly Bill 2446 requires that CARB, the California Air Resources Board, develops a carbon trading program for whole building LCA by 2026. So while that just passed, it's not going to be out for a while. And new legislation will be considered for a materials approach that will look similar. I don't want to leave refrigerants out of the conversation. There's a lot that's going on with the California Air Resources Board around that. They've been directed to reduce their global warming potential of specific refrigerants. So we'll be seeing a lot more there. Within CalGreen, there is a proposal that is being considered, and there are there are 3 different options for a single requirement. So this is this draft that's up on the screen now. This would be required for projects that are over 50,000 square feet, and then additional requirements for tier 1 and tier 2. And again, the embodied carbon one of these would be required, and you would just choose which one. So looking at building reuse, whole building life cycle analysis, or using a prescriptive approach that is pretty similar to what we see in Buy Clean California. So the reason why codes are important is because we want to work within existing regulations, and the building code includes those requirements for materials and can address embodied carbon requirements just as it addresses other requirements. So we can look at embodied carbon in the code in a few different ways. It could be materials level, which is similar to what is happening with, what's happening with Buy Clean. We could look at a systems level where we're looking at just the structural system or the envelope, or looking at a whole building LCA. So all of this is kind of exploding right now, which is really exciting. The Inflation Reduction Act is a federal law that allocates billions of dollars over many, many years, including millions of dollars to support the development of low carbon products. There's also going to be unprecedented funding to support manufacturers to create EPDs and low embodied carbon products. Most notably, there is $250 million allocated for an EPD assistance program with funding available until 2031. So there's billions of dollars that are going into this, and it's really exciting time to be involved with embodied carbon, and having this transparency on our products is going to be really important to have these high performance healthy buildings. So from here, I am going to hand it over to Brandon to talk more about concrete.
Thank you, Webley. Trying to advance the slide here. So to kick things off, just a quick introduction on my front. So I'm Brendan Ray with the National Ready Mix Concrete Association. So the association that represents a significant portion of concrete volume throughout North America. Specifically, I think we represent about 60 to 70% of the concrete that is ultimately in place. My role is heavily focused on supporting the design industry in terms of just best practices and education and everything within concrete in and of itself. The reason we're here today is to talk about reducing concrete's carbon impact, and as a kind of an introductory segue to this whole thing, I just want to highlight why it's critical for all of us to, in the design build community, to design smartly and to reduce the embodied carbon embodied carbon footprint, I should say, of the built environment. So, according to the UN Environment Global Status Report in 2017. The world is projected to add about 2.5 trillion square feet of buildings by 2060. That's essentially double the existing building stock that we currently have. And some fun figures some of us have probably heard is, a new New York City every month and things along those lines. So there's obviously a ton of just moving parts going on behind the scenes that we kind of are, naive to, that we don't necessarily see when we go about our everyday lives. So when we talk about designing smartly, we want to make sure that as these environments are being built, that we're using, designing disaster resilient buildings, because the best building is the one that you only build once. On top of that, looking at low energy and zero energy consumption, and as well as reducing the embodied impacts of the materials that are going to be used. As it pertains to concrete, Webley did mention the cement production globally contributes to about 8% of global emissions. And it's important to note that there are a few variables here, and most specifically is the unit rate of impact and the volume. And so on the volume side, concrete is the second most widely used material on Earth, second only to water, which is kind of an amazing figure to even comprehend. But the goal here is not to erase the use of concrete, but to use it wisely and efficiently, and to really put our best foot forward with reducing the unit rate of impact. So when we're talking about reducing the global emissions that come from this, is to really use it smartly and everyone kind of coming together to put forward the best practices. Ultimately, because of concrete's thermal mass, concrete has been the material of choice for energy efficiency, and that absorbs and desorbs heat energy and helps normalize building energy demands. And because of its strength and durability, it has also been the material of choice for disaster resilience. So ultimately, the challenge here is going to be to offer all these benefits, but at a lower carbon footprint. Building materials and construction have that global impact in the realm of about 11%, which I think was highlighted earlier. It's also in AIA, or I should say Architecture 2030. But when it comes to concrete, we just need to put our best foot forward. So before getting into some strategies, I just want to highlight some kind of the road that NRMCA itself has gone under. So how did we get here? NRMCA did start our journey towards carbon neutrality in 2009 by adopting a carbon reduction goal of 30% by 2030, among other impacts such as energy use and waste and recycled content as well. But that was the initial focus and an initial goal. Come 2012, we became an adopter of Architecture 2030 Challenge, which is basically stating a goal of 50% reduction in carbon footprint by 2030, followed by an embodied carbon neutrality goal by 2050. So that was a goal that we adopted in 2012. Ultimately, the Architecture 2030 Challenge did emphasize the use of life cycle assessment and environmental product declarations for measuring progress, because you can't reduce what you don't measure ultimately. Following this, we launched our EPD program and published benchmarks for carbon footprint reduction, or just carbon footprint monitoring, I should say, in 2014. We are a independent verifier of EPDs. These benchmarks and EPDs are routinely updated and allow for tracking of projects. And as I previously mentioned, you can't reduce what you don't measure. So this is an area that we see the potential benefit of funding from the Infrastructure and Investment and Jobs Act and a few other things, where we can actually be a resource and a conduit for managing those funds and helping, whether it's producers and other entities within the environment, to help get them access to EPDs specifically for our members. Because even though we do have a lot of EPDs, there still are a lot of places throughout the country and even within certain markets that have a lot of EPDs where smaller producers don't have them available to their operations. So being able to facilitate the advancement of those as well. In 2016, we launched our Build with Strength initiative, and that was really just focused on, again, supporting the design build community in terms of education and advocating for sustainable design. And in 2021, we adopted and helped support the Portland Cement Association's roadmap to carbon neutrality by 2050. So on the progress side, just from between 2014 and 2021, so like I mentioned, we started tracking our, or establishing EPDs and tracking progress in that time period. So over that 7-year window, our members had reduced their embodied impacts by about 21%, which is great and in line with our goal. Throughout that time, we've generated about 40,000 EPDs, which is kind of an amazing figure. Every concrete mix design essentially can have its own product-specific EPD. There's so many different formulations. There's not just one singular concrete out there. And as a comparison, just a note for what this looks like among other building materials, I believe all the other building materials combined have in the realm of about 200 EPDs or so. Just a general figure there, just to give some emphasis on the magnitude. But as you can see, tracking progress to get towards that goal. Some other things that have gone on specifically to the state of California, the California Senate Bill 596, which is basically a bill focused on, the first bill I should say, focused on any particular sector to help facilitate the industry to moving towards net zero emissions essentially. And so this was enacted and with huge support and contribution from the cement and concrete industry. Really focusing on decarbonizing cement and the steps to get there, because it's important to note that it's not necessarily as easy as flipping a switch. And I'll just read a few lines from that bill really quick, just to highlight kind of the intent here. So it does, emphasize that the climate emergency, is an urgent threat to things within, in all aspects of life, and more specifically, California's cement and concrete industry is well positioned to lead and accelerate commitments to achieve carbon neutrality. And this really stems from the idea that there is a wide range of commercially available technologies and practices that exist right now to reduce and remove emissions. But these technologies and practices face a series of market and regulatory barriers that hinder their deployment. So really this is focused on just aiding and that kind of push and pull emphasis on advancing these technologies and getting them into the market and being used. And as I mentioned, this was largely championed by our partner association, California Nevada Cement Association. So this is just a quick snippet from a document they have on their website. I encourage you all to check it out, but it's really just identifying the different levers, the 9 levers that are needed to kind of work towards the progress of achieving carbon neutrality in cement, and just really identifying critical areas of support and progress needs, whether it be legislative assistance, regulatory assistance, or funding and R&D, things along those lines. So we have these outlines and maps set up, and we're all working towards it. And another quick highlight, so looking at just the impacts, California-specific emissions, where they all stem from. So identifying the different sectors, from transportation to industrial and all that, and then looking at them broken down into a smaller factor. And now this, I just really want to emphasize, this is not trying to downplay any particular category or material or whatever it may be. The cement figure there of 2% of California's emissions is one factor that comes into play. But what really we want to do here is highlight the fact that it kind of takes a village, that mindset of it takes a village to achieve the goals that we set out before ourselves. And so we need to make sure that we're doing everything we can within our scopes of influence, but also seeing how we can beneficiate and help the other scopes as well. And so with concrete, I'm going to touch on a few things where we talk about improving operational energy needs and demands, and a few other things as well. So strategies now specifically, interesting enough, there are a lot of solutions involving concrete that have been around for decades. And when I say that, a lot of people are kind of surprised. They are tested, researched, and ultimately tried and true in nature. They often have original intents that were for beneficiating concrete in other aspects, such as improved durability or increasing efficiency. Ultimately, though, concrete is a lower margin industry, and motivation to change things up is really kind of on an as needed basis or specific design intents that or sustainability might not be deemed important. And so this is looking back, over the past many decades. Fast forward to today, though, and we find that sustainability is a huge focus and is a primary contributing metric when it comes to projects. That's where we kind of move forward with these technologies and researches and opportunities to better our built environment. So we need to create a design environment in which we're accepting of these means and methods and essentially pulling them into focus. This is going to be paired with a push from producers and manufacturers and technology developers to further advance these materials and technologies. So on this next slide for life cycle analysis, I'm not going to go into depth here as this is already covered by Webley, but I just want to highlight the three different stages of impact. And concrete does have a role in all of these stages. It's always going to be important to look holistically at a project when quantifying impacts, because a fun little analogy I like to use is with electric vehicles, for instance. So manufacturing of an EV is heavy on the front end of a product stage compared to an internal combustion vehicle, but after around 20,000 miles of use or so, there's a net benefit that comes to light. And so with concrete, we want to do everything we can on the front end to reduce its impacts and make sure that we're capturing and improving the operation on the whole life perspective. So where can concrete come into play with this? First, on the embodied side, concrete is largely a local material. So water, sand, aggregate, all these ingredients make up about 85 to 90% of concrete mixture by weight. And the process to manufacture and procure these materials really is local and minimizes transportation to the construction site, as it is less a local material. So the amount of embodied carbon in concrete is primarily a function of the cement in the mix. So therefore, one of the most effective and immediate ways to reduce the embodied impacts of concrete is to increase the use of industrial waste and byproducts that replace a portion of the cement within concrete. Ultimately, as cement is the most expensive ingredient, this is a relatively easy thing to do. You have to monitor supply and availability and whatnot, but it results in often realizing net benefits to sustainability at negligible cost impacts. And some of these waste materials can be fly ash from coal burning, coal-fired power plants, slag from steel manufacturing, biochar from wood waste, and also from municipal waste, just to name a few. And we'll touch on some of that a little later, a little more in depth. Next up is going to be your operational. So your use stage benefits of concrete can include certain things like the thermal mass, beneficiating energy demands and energy curves, both in magnitude and timing. I kind of touched on that. And also just the overall aspect of it being resilient and durable in nature. That's just kind of the nature of concrete, and will reduce maintenance needs while also increasing the reliable longevity of the building. And lastly is just going to be your end of life benefits, include carbon uptake, where concrete will actively absorb and permanently sequester CO2 from the atmosphere throughout its life. This is a phenomenon called carbonation. Won't go into depth here, it's a little bit of chemistry, but overall concrete does absorb CO2. Also concrete can, at the end of life can be crushed and used as an aggregate for certain percentages and certain classes of mixes back in concrete, and also used as a base material as well. So the embodied carbon of concrete constituents, looking at where the impacts are, when we look at the constituents themselves in a concrete mix, an interesting observation can be made. As an example here, we see the ingredients for a typical 4,000 PSI mix with no supplemental cementitious materials. Notably, you'll pick up on the fact that aggregates take up about 70% or the largest amount of material within an actual mix. But when we look at the carbon impacts of these ingredients, we're going to see that cement kind of stands out as having an impact of around 85%. So despite being 10% of the volume, it has an impact of about 85%, which is overly weighted towards the cement ingredient. So as you can see, cement manufacturing and usage is the primary contributor to global warming potential in a concrete mix. And offsetting the use of traditional cement is going to be a plug-and-play solution to reduce emissions. And this is really the beautiful thing about concrete specifically. Much like the proportioning and baking of a cake, there is just not one single recipe or way of doing it. And our industry is unique in the ability to use a wide range of materials while also already having the performance standards and code infrastructure to ensure their performance and allow their usage. So here we'll get into a few of those strategies a little more specifically. Here we look at reducing the cement's carbon impact, and this is just done through using innovative cements, as we previously mentioned in terms of cement having the largest impact. What this means though, and how do we do this, or how is it accomplished, I should say, is simply the use of ASTM C595 for blended cements. This is compared to your traditional ASTM C150 cement, which is your everyday cement that has been used for quite some time. I won't go into too much detail, but in fact, we'll just kind of skip over this, but cement is basically, there's an ingredient within cement during its manufacture that is the carbon intensive portion of it. It's not just the burning of material, but also a chemical breakdown of material. And what we want to do is basically reduce the amount of fired and processed material, which will directly relate or translate into a reduction in carbon emissions. So there are several blended cements that combine OPC or ordinary Portland cement with other materials. The most common is going to be your Portland limestone cement, often called PLC, which is basically your ASTM C595 type 1L cement. And this is becoming more and more prominent within the market, as I think 48 out of 50 DOTs have officially accepted it, and production is more or less transitioning to be the primary material. But this basically combines about 5 to 15% of limestone interground with the traditional Portland cement. And basically what it does is it reduces the impact by about 10% or so. And it's important to note here that we're not watering down the concrete, or the cement, I should say. It's more or less producing an engineered material that basically behaves and performs the same. There are other ones on here as well. You'll see Portland slag cement, Portland pozzolan cement, and ternary blends, and they're available in certain markets, and they should be used whenever possible. But the important thing here is really to highlight the fact that we want to be accepting of the standard, and if your specification says, hey, C150 cement is what's allowed on the project, you're not going to get these innovative cements that are basically plug-and-play solutions to reduce your impact. And this is a good little visual here of what we're talking about. So on the left there, you see the Portland Cement Association's national industry-wide standard impact compared to the two in the middle there are California typical cements for your ASTM C150. And then going into the blended cement, you can see a 10% reduction for the type 1L. So next up, just specify supplemental cementitious materials. So Many, if you're a designer or an engineer on the call, you are somewhat familiar with this already because most concretes these days already do have SCMs, is what we call them, as part of the mix design. These are typically going to be your fly ashes or your slags or silica fume, but there are other things as well, like calcined clays and volcanic ashes and ground glass. Overall, most of these are either going to be waste byproducts of other industrial processes or naturally occurring materials that require little processing and therefore have smaller carbon footprints. Important to note here, all of these materials do enhance the performance of concrete. So again, we're not watering down the concrete, we're actually improving it. And a lot of those standards I mentioned before in terms of being tried and true and researched and put into practice for many decades, they were done with this in mind for improving durability and efficiency of concrete, but now we're more or less leveraging and pushing them forward for largely on the sustainability side. And a good visual here of the impact of SCMs on embodied carbon, just looking at a 6,000 PSI mix at 28 days, 100% cement versus 50% replacement versus 70% replacement. You can see very similar corresponding reductions of 45 and 60%. We understand that you're not going to blanketly reduce or put 70% into your concrete mix for all applications because, whether it's supply limitations or constructability limitations, but you should always be surgical in your approach and use them whenever they're available. And as mentioned, they all improve the performance of concrete from reducing permeability and improving durability. But they also all have longer strength curves as well. So it's important to note that when you're designing to allow for, say, 56 days instead of 28 days, because one thing I like to highlight is we look at these replacement mixes, okay, there's 6,000 PSI at 28 days. Technically with SCMs, the reaction takes place over a longer period of time. So this 6,000 PSI is actually going to be more like 7,000 or 8,000 PSI at 56 days. And so you're going to be even further over designed. So you can incorporate these materials with adjustments to their strength development time, and it only further advances this reduction beyond even to that 50%. And this one is really just quite simple. It's just a matter of listing the standard, but not limiting the quantities that go into the mixes themselves. And next slide here. Last, just to close this out, is just don't limit ingredients. So this, covers certain things as maximum water to cement ratio, minimum cement content, or maximum SCM content. All too often, there's kind of seemingly random limits on material ingredients and project specifications, and this really hampers the ability of the producer to meet performance criteria as well as cost and carbon footprint criteria. So it's important to not incorporate these things unnecessarily. Now, there are going to be cases where you do need these, whether it's for design and durability needs. And if that's the case, they should always adhere to and follow ACI 318's code-based exposure classes, but they shouldn't be blanketly applied. And last, just to highlight a few resources to close out the discussion on concrete. Here are some things that are publicly available. We have our industry LCA benchmark report, which can be used with our industry-wide EPD for setting goals and tracking progress. So setting carbon goals or carbon targets, and then tracking progress individually and reductions for our project. We also have our guide specification for transitioning to a performance-based spec in place of a prescriptive approach. And lastly, we have a wide set of educational resources available through our Build with Strength Coalition, which is the part of the NRMCA that I'm with. And it really focuses on such things. We have 3 of them here, are, top 10 ways to reduce your concrete's carbon footprint. There's another one for specifying sustainable concrete, life cycle analysis of concrete structures, and the list goes on and on. So make sure you're capturing those and looping us in, because we can always be a resource for your teams in terms of whether it's setting goals or just improving the efficacy and efficiency of concrete on your project. I think now I'll hand it over to Luke.
Luke, you may be
Hey,
whispering.
Luke, are you on mute?
Sorry, the headphones must have come out. Hello.
We can hear you.
Can you hear me, Brandon?
Yeah, I can hear you.
Okay, there we go. All right, we tested all the audio and you'll always have, I guess, hurdles. So I'm going to start over. My name is Luke Lombardi. I'm a structural engineer and sustainability consultant with Bro Happold, and I want to thank Brandon and Webley for their perspectives. And my role here is really to provide the perspective of a practitioner. And I borrow this image to start from my colleague Kathleen Hetrick. And I think it's important to talk about, as we're thinking about policies and roadmaps, that there can often be an implementation gap on projects. In theory, theory does not always match reality. And what we want to talk about today is really how can we reconcile these macro level plans with micro scale, project scale implementation. And okay, there's the slide. And so we're going to break this up into 4 sections and start by talking about social change. How do we engage together? And then share some strategies and lessons learned. This is not going to be comprehensive. I think we're already pretty ambitious on the scope here. And so lastly, we'll wrap up with vision for the future. And along the way, there'll be lots of resources and different orgs. And I hope that people use these as signposts and ways to jump off and learn more. So I'm going to start with this presentation that or published report recently from RMI that I got a lot of optimism from, that talked about change being nonlinear. And it reminded me of that quote, "Never underestimate the power of a small group to change the world." And as we're starting to push embodied carbon change in the industry, I think we're starting to hear this topic more often, and just the fact that we're having this webinar is an indicator that things are changing. And we're seeing that too in things like EPD development. And it's exciting to see some of the policies that Webley mentioned, and things like the Inflation Reduction Act will only add to this momentum. And it's having interactions with Webley and others around the Cal Green Code, and exchanges with Brandon or local ready mix suppliers. It got me really thinking about what I'm going to call this nexus of public, private, and policy. And I'm very much not a poli-sci person. I'm an engineer, so there's a very simple diagram. But what I want to make a point of is we're part of this complex system, complex ecosystem. It's like that push-pull that Brandon mentioned, and that with each one of these sectors, and with many groups kind of influencing them, we start to set precedent for each other. And there's no linear process, but rather we're able to make progress by each one kind of showing precedent. And as for example, private sector, we can't just demand policy. We have to show that we're prepared for things like whole building LCA and indicate to policymakers that this is something that we're ready for. And an example of that, I think, is that what we mentioned is the Buy Clean Act. In California, public projects now have to meet global warming potential limits, and this is indicated to the industry that we need to change. We need to make common practice development of things like environmental product declarations, and seeing folks in the public sector also reacting to this. The GSA has been a big indicator that they've started publishing also concrete limits, and as the biggest purchaser in the country, that sends a market signal that then can also be picked up by public projects. And the importance is really setting and sharing precedent. And just also want to give a shout out to Anish Talak, who we've all been working on with on Cal Green as well, and recently published work around roadmap for reaching zero embodied carbon structures in federal projects. This is also kind of a next step in creating precedent and looking at setting limits for LCAs and things like that then we can continue to talk about. And that's, I think, the biggest takeaway here is there are many groups starting to form, and I've highlighted just 2 here, but sharing precedent is really key. If we're going to meet any of our climate targets, it doesn't matter if we have one project that's good, we need broad adoption. And the biggest thing that we can do in this climate transition is to talk about it. Talk about embodied carbon, meet other people who are interested in embodied carbon, and find those different avenues in our complex ecosystem to make changes on our project. Just to highlight a couple things, SC 2050 is a program that started just 2 years ago and now has over 100 signatories and many people publishing lessons learned in their embodied carbon action plans, and I'll get to that in a sec too. There are lots of other organizations depending on what kind of practitioner you are, and for that I would just point to the CLF, who does a nice summary of everything that's going on quarterly. So how are we actually adapting to our future needs? And for this, again, I'd rely on the model that SC 2050 has, which is every signatory firm has to publish not only data to whole building LCA data to a central database, but also their plan for and lessons learned for embodied carbon. And all of this information is published publicly on the SC 2050 website, along with a point person who you can contact. And a theme you'll start to see with these is really communication. And our biggest communication tool as designers with embodied carbon is life cycle analysis. And for those who aren't, you haven't done much life cycle analysis, simply it's taking the aggregate of material quantities and multiplying by global warming potential. I think it touched on a little bit earlier in this presentation, but the key for this is really communicating early on in design with owners, with architects, the vision for the project and which variables we can adapt so that we can find greater optimization and look at minimizing material, minimizing high impact material. And one main big point that I want to make with this is that we found that a lot of times when you're looking at optimizing material, it also is correlated with lower costs. So finding the kind of avenue and talking points that are aligned with decision makers on your project, I think is key. If an owner isn't interested in embodied carbon, talking about costs may be an important thing. And having a relationship with GC to talk about costs can be key in having a successful project. Another part of LCA is just identifying kind of the hotspots of where we should focus the most attention. From doing these studies, we know some kind of high level things like, the structure is one of the biggest components, and Webley talked about, and of the structure, the floors are the biggest single design component because there's so much of them. But not just that, we also know the foundations are a pretty significant component, and with that, we often have more influence over that aspect of design. And also just to flag that by doing these LCAs, I think we indicate, to the industry that the practitioners are ready for whole building LCA policies, and this can also feed into that nexus of public-private policy development. But talking about foundations leads me to talking about concrete, and Brandon did a great job of covering most of this. That NRMCA top 10 list is a really good resource. But I just want to reiterate a couple of things, and that is mainly around communication. And one of the biggest strategies that we're seeing is moving towards performance-based specifications to really communicate what's important to each discipline and allow each party or representative to optimize their system. So as structural engineers, we care about strength and durability, and we can alleviate some of the pinch points for ready mix suppliers in making the most effective mix design. And part of a big point of discussion on this is talking about what should that limit be. And I think right now there's a couple ways of, a number of ways of looking at that. You can use existing data. I highlight EC3 as a great resource to compile what's available. but there isn't data everywhere. So you can also look at inter-MCA regional averages. I think these are looking to become more granular in the next year or so. But the biggest one I would say is actual supplier conversations. Talk with local ready-mix suppliers and build those connections. And I just want to highlight what this looks like on a bigger project, the work of a colleague of mine in Los Angeles, Margot Burkholder and Walter P. Moore. This is a big stadium project, and you can see that you know, there is some compromise in doing this. As you're having this conversation, it might not be the best embodied carbon solution, but it's better than you know, not doing it at all. And just to highlight one other strategy that from feedback from the industry is moving towards carbon budget limits rather than individual limits by mix. And for the sake of time, I have to skip through this a little bit, but I also just want to say having a contractor on your side is critical, and that we've had issues where embodied carbon strategies haven't been implemented because if you ask later, it can lead to change orders and be a cost problem on the project. But having folks like another one of my colleagues that I want to point out and highlight, Jesse Buckmaster, that a lot of these, all of the products on this list, she was able to find cost neutral, low carbon alternatives, with the exception of drywall, which was a 0.1% increase. Anyway, again, very optimistic on the content here, but gonna fly through a couple of quick case studies. This one comes from Philly. It was a university client, so they had sustainability goals. We worked with Lake Flato, who's also a big proponent of sustainability and embodied carbon, on looking at different scenarios and relative performance early on in design. Ultimately, a mass timber excuse me, project was selected, which is exciting. I believe it was the first mass timber project in Philly. And throughout this process, we used our open source tool, the BOM. If there are any Grasshopper users, this can be a real good way to do LCA and communicate results. And the other quick case study that I want to show just touches on reuse. And this is something we're seeing more often, is showing clients, you know, how much of a environmental impact is there from choosing to have a targeted rehab approach to a building rather than tearing down building new. And when you're doing these, it really jumps out to you how much material is in these buildings and the significant impact that we have. And so just very quickly, by using this targeted approach, we are able to show significant, as you can imagine, embodied carbon savings in the structure alone, as well as doing things like mitigating a significant amount of waste that would have gone to landfill and water that's used during demolition. And I just point to a tool that came out recently at Greenbuild that is for owners and developer or architects who are facing these early decisions, called the CARE tool, and you can run some high-level scenarios on this. So in closing, I just want to look at, you know, where is this headed? Right now, we're really looking at incremental reductions in sustainability, but as we get lower on that embodied kind of climate action reductions, like high-level goal, I think we really want to look towards, you know, more restorative practices and even regenerative practices and what that means to the building industry. And as we go down that route, I think we'll find more and more on you know, the compounding impacts to material health, waste, forced labor. You know, this is not just a carbon pollution problem that where our materials come from. It has deeper impacts. And I would just leave the group with this kind of call to action, that finding hope in acting is really where I think there's a lot of potential, and there's a lot of groups and people out there, and I find hope in, you know, folks like Brandon and Webley too, and working with them. So hopefully there's a little bit of that of useful content that people can get out of that. I think that'll close things for us. We have a number of resources, and we'll share this deck, I think, with the group. Webley or Izzy, is there anything else you want to jump in? I think we're going to be short on Q&A.
Yeah, thanks, Brendan, and thanks, Luke. If you're new to Embodied Carbon, we threw a couple of resources in here because it can be hard to know where to start if you're new. There's so many great resources out there. Brandon, Luke, and I pulled together some of our favorite resources. That's not to say that we don't have other favorites. It's hard to choose your your favorite child, right? So if you're looking for a specific resource, you can feel free to email us. I'm going to throw our emails up on the screen in just a second. I also want to remind everyone that this webinar will be a resource and we will make it available publicly. It'll probably be all of our new favorite resource. So if you're looking for continuing education credits, answer the survey that's coming at the end of this webinar if you're listening to the live portion, and fill that out. Otherwise, you can email Izzy, whose email was at the beginning of this session, if you're watching this recorded. So I am going to ask everyone if we can, I'm going to turn on our video, and Izzy, if you can stop sharing the screen, that would be great. And Ryan, are there any questions in the chat for us?
Yep, great, thank you. And we do have a lot of questions, and so we will try to do 3 pretty quickly here, but we've got one for each of our panelists. So Luke, the first question's for you. It is, how do we account for the interaction between operational and embodied carbon?
Great, yeah, thank you. I think the answer to that is really running these life cycle assessments, and it's been a goal to take a broader approach, a more holistic approach to carbon, similar to how Webley was talking about MEP and those systems, trying to have a more comprehensive perspective, and that I think also goes beyond just carbon and looking at other impacts. But my answer in short would be doing the life cycle assessments and comparing different scenarios, because it also gets really interesting when you look at grid decarbonization, that the big impacts that has on long-term trade-offs with operational carbon.
Great, thank you, Luke. We appreciate that, and we'll have certainly more questions for you to answer offline. We'll do that via email after the webinar. There's been a whole bunch. Brandon, next question is to you. The question is, just having an EPD does not necessarily mean the product is low in carbon. How do you decipher between one product or another just by having an EPD? And Brandon, I think you're on mute.
Yeah, great question there, and that's a battle we constantly have, regardless of who you're associated with, because very easily we intuitively want to compare one to another, right? That's the default way everyone goes, but really it's more within its own silo. So for concrete specifically, of a concrete EPD for one mixed design, you can compare it to another mixed design, but you need to make sure the parameters of usage and application are the same, right? So you have a 4,000 PSI mix to go into your driveway, right? You have an EPD for that, and you have an alternate EPD that might have a lower impact for that same 4,000 PSI. Great, you can make a decision in that case, we'll go with the lower carbon one, but you need to make sure that there's other factors at play that you take into account from workability, pumpability, finishability. So if you need to pump the concrete 400 feet to get to that driveway, as opposed to it coming straight out the back of a truck, that can impact it as well. So it's very important to note that you're not gonna be readily comparing everything across the board, whether it's steel to concrete, wood to concrete, whatever it is. You need to look at just material to material and application to application. And that's where you make those, I call them kind of like micro, macro LCAs, right? You're looking at one element within the structure and you're making a decision for that specific element. This beam, for instance, we can do a column that has, it's a smaller footprint column, but it has a higher impact GWP, but the volume to impact plays out better than if we had a larger column and a smaller impact per unit rate, right? So it's more that juggling act, but those decisions are going to be made by the practitioner on the project and at multiple stages, right? You're not comparing products in the whole building per se, but doing the whole LCA, whole building LCA will play into that and give you some options there.
Excellent, thank you, Brandon. We've got time for one more question, and again, we'll take a lot of these offline and follow up with folks. So this question's for Webley. It is, how important is carbon when compared with methane? And do we have metrics for carbon dioxide equivalent for methane in construction, as in the production of that material?
Yeah, that's a great question. We all kind of use carbon as an off-term language when it's really carbon dioxide, but really it's greenhouse gas emissions. There's a lot of different gases that are included within when we say carbon, kind of in off the cuff. So there's methane, there's nitrous oxide, there's so many sulfur, there's so many other things that we need to consider in there. And I think that we can probably take the rest of that question offline, because there's a really cool chart that I can share with the person that asked that to kind of show how all of those different emissions break down into what we are calling carbon dioxide equivalent, essentially CO2e.
Great, thank you, Webley. So I think that is the time that we have for today. So we greatly appreciate everyone's participation. Again, we will follow up with a recording and slides and additional answers to questions. So Luke, Webley, and Brandon, please look for that on email, and we will make sure to circle back with you all. So thank you, everyone, so very much. And any final comments from the presenters here?
Thanks so much, everyone.
Thanks for having us.
All right, and that concludes today's webinar. Thank you, everybody. We will see you on the next one.